NEML number two. Boy, was that a hard one. We had almost 200 Wheeler students take that NEML, and only 2 students scored anything above a 3. There were no 4s. Daniel Schimberg scored a 5, and give it up for Eric Tang, who pulled off a perfect 6. But yeah, let's go over how to do these problems so that maybe you have a better fighting chance in the future. So let's start with problem number 1. Problem 1 states that if x minus 1 over x plus 1 equals 2019, what is the value of this expression? And hopefully you would look at that expression and notice that it is just x minus 1 over x plus 1 squared. Your numerator has been FOILed out. Your denominator has been FOILed out. So you just have to square this. So you have to square 2019. 2019 squared is 4,076,361. You can use a calculator if you want. Who wants to square that out? Please don't square that out. That's a lot of time. All right. Next, problem number 2. What is the least prime number which can be written as the sum of 2 composite numbers? Let's do a quick review of what prime numbers and composite numbers are. A prime number is a number that has exactly 2 factors, 1 and itself. So some primes are like 2, 3, 5, 7, 11, 13. A composite number has more than 2 factors. So composite numbers would be like 4 because it has the factors 1, 2, and 4, or 6, which has 1, 2, 3, and 6. All right. Now the number 1 only has 1 factor. So it is neither prime nor composite. So for those of you that put down 2 as your answer, now you know why that was not correct. You can't just add 1 and 1 together because 1 is not a composite number. Another thing to note, 2 is the only even prime number, and we want the sum of 2 to be a prime number. So if 2 is the only even one, that means the rest of them are odd. So to get an odd number, you have to add an even plus an odd together. So let's start with the smallest even composite and the smallest odd composite. So the smallest even composite is just 4. All right, we know it's not 2. Then you look at the next even number, it's 4. And for odd, you can just kind of go through them. It's not 3, 5, or 7. It is 9. You can also find them by just squaring the smallest even and odd prime numbers. And then lo and behold, 4 plus 9 does in fact give you a prime number 13. So we've got our answer. Number 3. Basically, we want to come up in this problem. It asks you to find how many integral coordinates have a separation of 5 from the origin if you're only moving along lines that are parallel to the x-axis or the y-axis. And the first question you might ask is, what the heck is an integral coordinate? Well, it's a coordinate pair, like x, y, with integer values. And you might be saying, well, what is an integer value? Well, integer values are numbers like -3, -2, -1, 0, 1, 2, 3. They're basically the counting numbers plus the negative counting numbers and 0 thrown in there as well. And so we can just start listing them out. You can go to the right 5 or to the left 5. So that would look like positive or -5, comma 0. So there's 2 of those. You could either go to the right 4 and up 1 or down 1, or to the left 4, up 1 or down 1. So I just wrote that as plus or minus 4, plus or minus 1, but that's 4 different options there. You could do the same thing for 3 and 2, 4 options, 2 and 3, 4 and 1. And then if you go 0, 5, you're either going up 5 or you're going down 5. And then there's 2 options there. Add that all up, and there's 20 total. And we are on to number 4. For this one, you have this point inside an equilateral triangle. So equilateral triangle, all the sides are congruent to each other. They're all the same. And we know that those lengths are 2 root 3, 4 root 3, and 5 root 3. This problem reminds me a lot of the surfer and the spotter problem. So if you are not familiar with the surfer and spotter problem, they're pretty cool. You might want to look those up online. But basically what I would do is I would take this diagram and I would draw in the following line segments from the point on the inside to all 3 vertices, and it breaks it up into 3 different triangles. So you've got this triangle up here, all right? And that triangle is 1/2 of S times A, and this triangle over here is has an area of 1/2 s times b, and then this triangle over here has an area of 1/2 of s times c. So the area of the entire thing, which is 1/2 base times whatever this height is, has to be the same as the sum of those three areas of those triangles. But you can factor out the 1/2 and the s because they're all the same in each of them, and you end up with 1/2 s times a plus b plus c. So this a plus b plus c, which is 11 radical 3, you just add the 3 up that were given to you in the problem, that's a constant. That's fixed. A plus, it doesn't matter where this point is, that is always going to be 11 root 3. But notice that because your base is just s, that's also your height. So your height has to be 11 radical 3. And now if you have a height of 11 radical 3 and you want to figure out what your base is, note you have a 30, 60, 90 triangle in there. So if you have a 30, 60, 90 triangle, you got 11 root 3, then this would be 11 down here. You got to double it because you have another side. So it's 22 is your base, and then you do 1/2 your base times your height. So 1/2 22 times 11 root 3 is 121 root 3. And we are moving on to problem number 5. All right. So you're given, in this problem, you're given a cubic, and you're also given it in factored form with these variables c and a thrown in there, and you want to find out all possible values of a. So you could use this technique called Vieta's formula, but you might not know Vieta's. I highly recommend looking it up, though, online if you're not familiar with these, because they do come up a bunch in math competitions. But if you're not familiar with these, you can also use your calculator. So how do you expand this on your calculator? Well, you type in expand, and then you just write out what you're trying to expand. You're expanding x minus c times, don't forget that multiplication sign, or else it's going to think you're doing some weird function thing, and it's not going to understand what you're doing. So x minus c times x plus a over c squared, and it will write it out as a polynomial for you. Why this is good is because you'll notice if you compare this to the original one, the first term is the same. It's still just x cubed. The last term is also just a. It's the same. So it's the x squared term. But notice the way the calculator does it is it has two different x squareds here. So you have to actually combine all these. So this was the tricky part, was to realize that's your x squared, which in the problem had a coefficient of c. So you have to set that equal to c. And then for your x term, you have this whole thing. You've got negative 2a over c plus c squared, and in the problem that equaled negative 5. So now you can solve a system of equations, though, and how you do that in your calculators, you solve first equation, you put space, and then your second equation, and then you do comma a, and the calculator will spit out your two possibilities for a, which are 3 and negative 3, and you're done with problem number 5. Moving on to number 6. What's the greatest number x for which the square root of x plus this thing, which is the greatest integer function of x, minus x equals 2? You might be like, what the heck's the greatest integer? Well, a greatest integer, you can think about it as, it's also called a floor function. Think about your age, all right? So like, let's say you're like 14, but your birthday was months ago. You still call yourself 14, all right? That's a floor function. You're going down to the previous number. Even though you might be like one day away from turning 15, you would still call yourself 14. So this is the same kind of thing. It's just working, you might have like a number like pi or something like that, 3.1415, and then the floor function of that is 3. You go down to the integer that's right below it, all right? And now you may have thought, oh, what if I just plug this in my calculator? The NSpire is super powerful. Maybe the calculator will just give me the answer. And you can plug this in your calculator. You just do solve square root of x plus, you type in floor. That's how the calculator recognizes it. It's floor of x minus x equals 2. And it starts to give you some values. But notice, it gives you decimal values. So the Math League, they knew, your answer must be exact. I think that they were on to that people might just do that. And so they didn't want to just have you plug it in and let the calculator do all the work. So you have to try to wrap your head around what this question is asking. So let's try and do that for a second. So we see up here that 4 is a possible solution. What would that look like? Well, if we plug that in, we'd have the square root of 4 plus the floor function of 4 minus 4. Well, the floor function of 4 is just 4, right? Because it doesn't, you are that number. There's nowhere to go down, And the square root of 4 is 2, and you'll notice that 2 plus 4 minus 4 does equal 2. All right. Notice the next one's like 5.30278. Well, what is that doing? So if we think about what's happening here, is we're taking the square root of 5.30278. The floor function of 5.30278 is just 5. And then we're subtracting the 5.3. So basically what we're getting is when we subtract the actual number from the floor, the leftover part is just the decimal piece. All right, all we're getting is the decimal piece out. And the square root part is it gives us another square root. So we want the decimals to cancel out and to just be a 2. So we're basically, what we're being asked for is take the square root of something such that the square root of it is 2 point, and then the decimal is the exact same decimal as what you had above. Now, one way to play around with this, before we play around with this, if you keep going though, if you think about the next perfect square, because that floor function would be 9. So the square root of 9 is 3. The floor function of 9 is 9, and 3 plus 9 minus 9 equals 3. We want it to equal 2. So we know this value has to be less than 9. We know that once you get to 9, we're going to be beyond the 2 range. So we need to stay under 9 but over 4. So here's what you can do. Let's take our value x. Let's break it down into its integer part, all right, before the decimal, and then the decimal part. And one way to rewrite this then would be that x plus d, so x is your z integer part plus your decimal is the floor of z plus d minus the number itself, z plus d. We want that to equal 2. And the floor of z plus d is just z. The decimal part goes away. That's what the floor function does, is it basically truncates. It takes away the decimal part. And so we have z, and then I distribute the negative over here. So you'll see how it's minus z minus d. And we still have my square root of x, which is z plus d over here. And then this cleans up nicely. So the z's cancel, bring the d over the other side, so you have this guy. Now, again, you don't have to use a calculator. You could just square this thing, but then you end up with having to use the quadratic formula. What you could just do, though, is plug in your calculator. Let the calculator solve this. So I'm going to plug in the square root of z plus d equals 2 plus d comma d. Now, I have a lot of variables here. Z can be different things, all right? Z could have been 4 or 5 or 6 or 7 or 8. We said it had to be less than 9. So let's start. We want the maximum thing. So let's start the highest place. Let's start with z equal 8. What happens if you plug 8 into this? So it could be 8 in some decimal, and you take the square root of that, it's 2 with that same decimal. Well, it turns out that the decimal part wouldn't actually be a decimal. It would be the number 1. So that doesn't work, because now that lops us up to 9, which is not the number that we're looking for, as we saw above. So let's go down one notch. Let's go down to 7. And if you plug in 7, you get your d value to equal this this number, radical 21 minus 3 over 2. But that's just our decimal part. We want the whole part, so we want 7 plus that. So take 7, add it to that, and lo and behold, there is your answer, all right? That's the number we're looking for. And if you actually take the square root of 7, put this in decimal form, you'll notice that the square root of this is 2 in that same decimal. So your radical 21 over 2 plus 11 over 2 is the answer, which, by the way, it was up here as well. If you scrolled over. So there it is. That's how you get a 6. It's doable. It's hard, but it's doable. So I hope you learned a lot from here, and happy NEMLing. I will see you guys next time. Bye.